So, I mean, Anthony, I'll just pick off and keep going until they go into the breakout room. I just wanted to say about that book.
Okay.
So it gets, I don't think it gets into, there's probably actually numerical examples about like the effects of what it looks like when you have a team in the factory doing profit sharing.
Mhm.
I just wanted to say that it gets into the technical details in terms of explaining the processes, and you understand like why they work in a given way. Like you understand why they work as expected. Just for example, if you have a dynamic where you say the employees can choose their own salaries, and the first thing is like, well, what the fuck is, good luck.
Yeah, what
Like
happens when this, that, or the other thing happens? Like when somebody
right,
else
right,
that's
right.
whatever, obviously.
Exactly. And so what he explains is he's like, I think like the employee teams or the squad who does a certain profit sharing group, first of all, they would have to like agree on something like that. So if somebody's asking for $1 billion to do 1 month's work, then the team would be like, no, that's kind of unreasonable. If a person on the team is asking for twice the amount of money that the other people in the team are getting, maybe they would do that for a month, and then the
Yeah.
team would evaluate. Like the team would make the decisions themselves in terms of
Sam,
looking.
did you see the
Yes.
message? I made you the host.
Okay.
So you'll have to let people in. I'm just
Okay.
gonna go. The breakout room didn't work out, so we're just gonna go and come back.
Okay.
Okay.
See you soon.
All right. I'll be here. Right. So the team would basically like look at their own finances and like look at their own production and look at their own profit share, and they'd say like, okay, is this person who's earning twice as much as us adding that delta in value? If so, like we'll keep paying it like it. If not, like the rest of the team, like we can fire him, or
Yeah, but
we
that
can
seems
say,
like a very crude approach. I mean, why don't you just reduce his pay? Because if you fire him, then you have to find somebody else who's trained and knows the system and stuff. It's going to be a significant hiccup in your little process.
right. I mean, and that you can like change the pay, like negotiation as well. Just the point is like it's the workers themselves in their team who are working together who are making the decision.
Well, it's still a negotiation process as far as I can tell, because when you're a normal employee in a normal company, you can ask for a raise. I mean, you might not get it. If the boss thinks you're worth it, you might give it to you. It depends if they know you have another job offer somewhere else, stuff like that. Like there's a whole bunch of different factors that go into negotiating. So in this case, it sounds like the workers are negotiating amongst themselves, which makes a lot of sense. And I'm a fan of that. But it's still a negotiation process. It's not like you just set your own salary. I don't. I mean, you could.
So that's like a nuance I don't exactly remember, but I do. I mean, okay, I wanted to clarify to make sure that it doesn't go out of the realm of reason, because if I say that you can like answer your own, you can set your own salary, then like what if somebody asks for $1 billion in a month? So maybe there's certain rules around that, but I think the book did indeed say that people can choose their own salaries.
Mhm.
I don't know if there's like a trial period where they do that at which point it's negotiated, or they like ask for a given salary, and if the team accepts it, then they accept it. I don't remember that nuance specifically.
Okay. Yeah. I was actually a member of a labor co-op in Ottawa. Me and some of my friends, after Occupy ended, we started a labor co-op. So we were just going to teach each other how to paint houses and do janitorial stuff. And like, it worked actually pretty well. We made like $25 an hour. It was pretty good for the type of work we were doing. And one of the things, we did have little things like that, but they were just vague ideas. They were like, okay, you're supposed to be able to set your own salary. So if somebody wanted to ask for $35 an hour, they could do that. But everybody knew that obviously if you ask for $100 an hour, then there's going to be trouble of some kind or another, even though it wasn't included in the rules. So there was like, yeah, we didn't do a very good job, but we didn't have anything to work with. Like if we'd had a nice protocol, basically written down, like not the general description of software, like these books, I'm sure they have great uses and they're certainly a start, but they're not the protocol. It's like a general description of the protocol, and it tells you some of the background of the protocol and how it came to be. But the actual protocol is somewhere buried in the heads of the people who work in the company. And to actually copy that system or try to reboot a smaller system, it's not an easy challenge when only you have the vague description of a piece of software. It's like trying to compile a piece of software and all you have is a vague description. You need the actual code, right? And converting the vague description into the code is a significant piece of work. So you have to know a lot about the details of the computer system, how it works and how it interacts with other systems and stuff like that, right? So yeah, that's one of my major criticisms.
Well, one maybe counterpoint I'd share with that is if you're trying to emulate a piece of software, so like that software is working there and all you have is like a description of it, that might not be enough to copy the software line for line, like you're shit out of luck. At the same time, if you like know the intention of that software and if you know its purpose, then like maybe the description itself is irrelevant. So let's say this, like that's like a C# piece of software that like runs on like Linux machines. And then you have people over here who are like, I don't know, like we're a Java shop and like we have different machines. I'm getting out of my hardware now.
I get what you mean though. Like even if you had the exact byte codes of the exact compiled software, you have a different machine anyway, a different context. So your compiled software isn't necessarily going to work very well. Or like
well, more of the point is that, like I could have a description of the software and like a description of what it does, what might not actually be so helpful for me in comparison to like what it's helping to achieve or what the purpose of that software is. Like it's different. So
you want documentation, right? Yeah, like
yeah, I guess my point in the co-op example, right, is that like maybe you don't have the protocol which might be in the heads of the people at that firm, but you can have an idea of what they're trying to achieve, and so maybe you can create your own protocol.
Yeah,
like
it's
based.
It's just that it's just one step away from actually being where you need to be. That's what I'm saying. Like, but I agree with you. Like, even if you did have their exact protocol, it may not apply to you anyway, right? And you may have to do a lot of work to adapt it to your own circumstances.
Yeah, and there's a really like hands-on example of this in terms of both. We haven't even talked about last week in terms of both the software and the organization side. So did we talk last week about like Loomio and Inspiral?
Yeah, we did talk about Inspiral a little bit.
Okay.
They have a piece of we talked about how they have a piece of software, but it only really fits into the context of Inspiral. Other people try to use it. They don't seem to have a whole lot of success because it's not the big picture. Like, it's not the whole thing, right? Yeah.
Exactly. And I've had this conversation with multiple people, and just this week, like yesterday, I have a friend who runs. He's in like Geneva. It's pretty cool. It's like I don't know. It's kind of like a hacktivist group, but like hacktivist meets art meets like exploring different ways of living.
Only in Europe.
Yeah. But so they like meet every week in Geneva, but they also have a lot of online people like me who aren't there, who will like kind of tune in, and it's been a really good kind of online community, let's say, like part in person, part offline, and also like not that big, maybe like 20 to 50 people. So it's like familiar. And so just this week, the guy who kind of does a lot of the work in organizing for that group was like, hey, like I'm thinking about self-hosting a Loomio instance to like help us express more, reactions to things besides just like emojis. I don't know, but my point to him was just, again, like, so what exactly are you trying to do with a Loomio instance? Because again, it's like, there's this vague conception of where you're trying to get to, and you see it working well over there. And yet that description of that thing is not necessarily the best thing to help you. And you're also missing the organizational protocol, which makes it work too. So that was just a hands-on example from yesterday.
Okay. Yeah, so you don't have to reach very far to see how this kind of thing is happening. But I also have sympathy for the idea that, well, people are trying to do something approximate, and they don't have the tool for exactly what they want to do. So they'll just pick a tool that does approximately what they want to do, and they hope for the best and try to proceed to action, see if they can do something useful of some kind. And their vision is usually kind of vague to begin with. It sounds like this guy's vision was a little bit vague. So he wants to take the tool and try to make something interesting happen.
That is exact, and I think that's a big part of the problem, part of the issue with this stuff. And I've actually been, I don't even know, the demo, I was having some issues with the demo. I'll try to get it online, but that lack of clarity. So the idea of the tool was just basically a graph where you can
Okay.
put in little text statements, and it's like, I want to do X.
Mhm.
So maybe you're saying like, I want to run a Lumio instance, and then you have to say, in order to do Y, like letter Y. So then like you say, I want to self-host a Lumio instance in order to do what? And then you're like, like what?
Whatever
What's
Lumio does, I guess.
but yeah, but like what specifically do
Yeah.
I want to do with Lumio instance? And then you can describe that, but then you're already starting to think like, the tool is a means to an end. So what is like
Yeah.
the specific clarified outcome I'm trying to reach?
Yeah, it's a good idea. Yeah.
But and so about the people group programming thing, um, I guess a question that came to mind while you were talking is like mm, hmm. So I'll just say actually, so do you consider like GitHub and the activity that happens on GitHub as an example of people group programming?
It's not what I was thinking of. There are groups of people that do collaborate and do some things sometimes substantial things, but there's a lot of orphan projects too where they don't really go anywhere. And when they do come together and get stuff done, the protocol, the program that they're running as a group of people is it wasn't specified by the people who started the GitHub program usually. If anything, it was kind of created it sort of evolved over time by patching together different things from society, little concepts that we have, concepts like the leader, bottom lines things, double checks things, make sure nothing falls through the cracks, the benevolent dictator model. And they may employ other systems like some consensus decision-making processes, sometimes without success, sometimes successfully. But I don't really think of it as much to do with people group programming because it wasn't very intentional. Like they just sort of, they evolve into it. And a lot of the time that doesn't work very well. Like it doesn't boot up. Like you get a small project, which is an interesting project and worthwhile, but it doesn't boot up for whatever reason. The people who are interested in it don't have the skills to form an ad hoc decentralized group. And there's no benevolent dictator, or if there is, the benevolent dictator is not a very nice guy or something, and it doesn't work. So yeah,
So
not really.
well, so something came to mind while you were talking, and I wonder if this is like the language thing that Lauren talks about sometimes in terms of like we're talking with different words. So would you say, when you say protocol, would you say that like pattern is a synonym for that?
No, it seems to be different. The protocol is like an if-then. It says, so if this happens, then you do this. And so it's got patterns in it, but I wouldn't say it was just a pattern. A pattern is kind of like, yeah, it's sort of like many patterns that are sort of on top of each other. It's got a lot of branching, and so there can be loops in it and stuff. It's more like a computer program than a pattern, I would say.
So I have something that I would be, so I can share it's a long short piece, but then there's like a free book. Well, are you familiar with Peter Hinton's work around like simplicity oriented design?
Peter Hinton, no.
Okay, let me try to find this. So the point is, he has this blog post which was really influential for me.
Mhm.
And I'm actually probably going to be describing my pattern or protocol in some capacity one of these days soon that I'm using. So there's the blog post, and it describes some like really important, really impactful anti-patterns. I'm going to say I don't want to say anti-patterns, like things that people waste a lot of time and money on.
Okay.
And then he has a longer version of this, which is a book. And it's an online book. It's called Social Architecture. There's some really fascinating stuff in here. Like it starts at a very personal place where he's talking about like burnout, and he's talking about like people. So I think there might be quite a lot that resonates with you.
Okay.
And what this book is describing is he was like the maintainer and one of the leads for some project that was like an open source project that ended up being used by like Facebook and lots of other big companies for sending messages, just some like really like hardcore backend infrastructure type stuff. And this book that I shared, he is like describing the processes that they came to, that they used in the development and the maintenance of that repository. And so I suppose what I was wondering while
That
I
sounds
was,
like a pretty interesting book. Yeah.
yeah, and so what I was wondering is if you would describe like the book or the description processes there as a protocol, or if it would be something else to
If it's in enough detail, yeah, sure.
you.
And I guess like there's a whole spectrum between this, from like same as when you're writing a computer program, you can make a very abstract description of it to help you write the program later on, and eventually it has to get into, you might write it in something like Python, and then the computer doesn't actually run that, right? It has to convert that into the bytecodes on runtime. So there's many layers of abstraction and description. It sounds like this is a little bit more detailed than usual. It's a specific project, and because it's software engineering, probably has more respect for getting the details in there. So that sounds like a very interesting book. I should have a look at, I guess.
Yeah, and so that was interesting when you said like the kind of the level of, so is that what you meant? Like the level of detail and specificity is what changes from like a process to a protocol?
From a process to a protocol?
Yeah.
I don't know. I mean,
You
from a
said
pattern. From a pattern to a protocol, maybe. No, a pattern to a protocol, I would say like a pattern to me, it doesn't sound like it has loops and stuff in it and conditionals. A pattern is just sort of a fixed thing. It's like an element which can be composed, and you could put many patterns together into a program. But well, you know, this, when it comes to what I think of as a pattern and what I think of as a computer program, right? They seem to be distinctly different concepts, right? Don't you think so? And my idea of a protocol is it's sort of one step up in abstraction from a program. It's like the Bitcoin protocol or something, right? The Bitcoin protocol is described in the white paper, but and not in great detail actually. And then there's more there's several layers of detail where the details get fleshed out.
Yeah, and so I guess my question then is about like the relative fuzziness, or like do you see room for fuzziness in protocols?
Root fuzziness?
Room for fuzziness.
Oh, yeah. Yeah, I do. So there's a difference between a formal language and a natural language too. There's ambiguity in natural languages, so you can't really write a program in them because there's several different ways of interpreting it. With a protocol, there should be, I think, only one dominant way of interpreting it, but the details of exactly how the communication happens, for instance, or the storage happens or something, yeah, that can be fuzzy because it's a guide for more detailed descriptions of exactly what to do.
Right, and so the concrete example I'm getting at is, so both in Peter Hinton's book and in the blog Simplicity Oriented Design, and in another book called Shape Up from the Basecamp people, which has been really impactful for me. So there's a practice. I'm going to say practice without saying this is process or protocol to describe, to see like how you think of it.
Okay.
So the common practice, it has a little bit of different shapes or kind of flavors or sequences to it. But the practice is that the way that people make decisions about like the next feature to develop is they compile a list of the most, let's say, kind of the simplest, most important problems to solve.
Okay.
And so they compile a list of the simplest, most important problems to solve, and they kind of cross-reference that with the amount of resources that it would take to solve a given problem. And the way they choose to work on what's next is like basically whatever they anticipate is the most impactful solution combined with like the lowest resource investment.
Like the best bang for your buck kind of thing.
Exactly, but yeah, so the specific angles there are like simplicity, impact, and then like resources or cost.
Okay.
So now, two people who are like considering that and they are well aware of everything could come to different opinions about what what is simplest, what is most impactful, like potentially even what are the costs involved. They should probably be on the same page about the costs. But I was wondering, when you think about a protocol, do you think that those 2 humans or 10 humans should all be seeing that in the same way? Or do you think a protocol can allow for differences? Can like the protocol allow for subjectivity, basically?
Well, that's a very interesting question. Like, yeah, and it has a lot of applications in this particular context, right? You've got a group of people trying to make a decision about how to do things. They're supposed to share a protocol. They have like a little book or something that has the protocol in it. That doesn't mean they're all going to make the same decisions. I think because you could never pack all that knowledge into the book, right? So in order to have your protocol a reasonable size that can be put into a human head in a reasonable time frame and remembered and used, yeah, I guess. But if you have a computer system, you say, here's a protocol, then I think generally speaking, the 2 computers should always make the same decision if they're following the protocol. So yeah, in the case of humans, I guess it's not really the same as a computer protocol. That's an interesting way of thinking about it. It's like 2 organisms or 2 entities, in the one case computers, in the other case humans, they have a rule set. But in the case of the humans, you can never really get them to reliably converge on the same decision with the kind of decisions that we're going to be making. So yeah, do you call it a protocol still? I don't know, it's similar to a protocol. Maybe it's not the same thing anymore. Yeah.
And so what that made me think about is what is the purpose or what is the utility of a protocol or a rule set?
Well, it certainly guides people to make coherent decisions. And it also, one thing is that it lets you know what other people are going to do in a certain context, or they're likely to do, so that you can coordinate with them without communicating quite so much. And you can predict the future to some degree. Like one of the things that to me was has something to do with most of the undertakings that we're talking about, but in a protest group, for instance, earlier on, well, since the 1800s, people recognized that it's important to not have too many leaders because it's easy to kill the leaders and stuff, or to arrest them, and then your group is non-functional. So it's important to do things in a decentralized way. And if suppose you're at a street protest and things are getting dicey with the police, they're getting more aggressive. If the people have a protocol, then they can make decisions as a group very fast and be surprisingly effective. But if everybody has no clue what's going on and everybody has a different opinion of what to do, then they can't think and act together as a group effectively. So that potential there is squandered, right? That has nothing to do with making any money, but it's or most of the types of undertakings that we discuss in these groups, but it's one example of yeah, people working together as a group. And if they had a rule set, a protocol of some kind, or I feel embarrassed to call it a protocol now because it's not really what I was thinking, because you pointed out that it's not a perfect term, but I don't know what else to call it. A rule set, call it a rule set.
Well, or I mean, so where my mind was initially going with that inquiry was somehow in my brain, protocol connected with heuristic, which is just like a shortcut for making decisions. And then I was wondering, like, well, like, is the purpose of all of this stuff, like rule sets, whatever you will have, like, I mean, I think you mentioned some good points which might not exactly fit into what I'm about to say, but is the utility of a protocol, of a heuristic, just simply to like lower the energy in decision making?
I think it also reduces the amount of communication required and the time it takes to communicate, because
Is that energy?
no, it's not the same as energy, I would say, because it's time too, right? You got your 3 units: distance, time, and what's the 4th unit? But anyway, it's not energy.
What like inputs? So like the time, the communication, those are the signaling, the receiving, those are inputs. Or
yeah, but also, like, if you have a real-time situation, like the cops are surrounded by, or the protesters are surrounded by police and things are getting different, it's not just a matter of reducing the amount of time it takes to make a decision, but it changes the outcome on an absolute basis quite effectively when the decision-making time is changed. And also, like the two outcomes, suppose on the one hand, everybody has a nice rule set and they all follow the rule set. On the other hand, everybody has a very vague rule set and they have several different copies, several different versions. The outcome is so different in either case that it doesn't seem to be constrained to just the use of energy or to the amount of time it takes to come up to to make a decision.
Yeah, that's true. And I suppose I would categorize rule set, protocol, process, practice. I would call all of these tools. I mean, I use this language a lot, but I would call all of them tools. So the reason for a rule set or a protocol is because it helps us, we think, in some way towards some certain ends or towards some certain outcomes. So a rule set in one case, it could be designed to like lower the time of making decisions. So an example that comes to mind is sometimes in sports, you'll have like specific, well, two things. You can have specific systems implemented by coaches, even at like the highest professional levels, that are designed to keep things simple to enable players to make decisions faster. So there's a set of rules in a situation, like if the ball is there, I'm going to go and like do this every single time because you're lowering the time to make a decision for that player so they can move faster. To the other end, there are systems which sometimes they work, but often they don't, where they require more conceptual work on behalf of the player. Sometimes it can work, but sometimes it works really poorly because they're making decisions slower. So now they're reacting slower, they're moving slower, they're kind of thinking too much. But that's very specific. You're talking about rule sets to help players, like to put players in a position to like do this certain thing in this bigger scheme. But I think you brought up a lot of great examples, like, you know, the reason why a group could choose to have a rule set is because it's like, we want to avoid issues coming up in the future in terms of like who has power in the group, or like the implicit or explicit power structures, or how we want to say now we want to behave in a certain situation when there's like uncertainty.
Yeah. Sort of box yourself in a little bit for the future, like give some inertia, I suppose.
Yeah.
Yeah. Certainly a very interesting subject. There's lots of potential there, but it's very difficult to do your experiments, partly because if you go to a group of protesters and you try to hand out a protocol, it's hard to have a decent protocol that people actually agree to. You have to show them that it was something they could trust. They do have basic protocol sets, like you get some advice, for instance.
Wait, hey, Anthony, can I get up really quickly? There's some people here who ordered some food, so I was going to get some food and bring it back. But I just want to try to get it while it's warm.
Okay, sure. Good
idea. But I'll be back in a couple of minutes.
Okay, sure. I'll read these websites you sent me.
I'm back.
All right, was there food? All right, you got something.
Mm. Yeah, sorry about the delay. I wanted to get it while it's warm.
Yeah, makes sense. That's a good idea. Yeah, sometimes these discussions, they get a little bit slow. But it's certainly a very interesting subject. What were we talking about exactly? I took a second to read or start reading some of these websites you sent me from Hingens.
Yeah, we were just talking about like what is the purpose or like why we use protocols and rule sets.
Oh, yeah, as people. Yeah, I mean, there's a certain embedded set of protocols and rule sets that we tend to carry around with us, and they're not all the same. It depends on the culture you're in and stuff. But that seems to be it's unwritten, and people give it a little more respect than it should have. Like they think that this is the one true way of doing things in many cases, and they don't realize that there's lots of other ways of doing things. But that's a major challenge. You have to get people to surrender their old protocols to some degree, or you have to know what they are at least. Otherwise, how are you going to write your program that works in concert with them? But everybody has a different set. But still, I think it would be a very interesting experiment if you get 10 people and you have to put your brains into writing a rule set to accomplish a task. And it doesn't have to be a super fancy task. It could be something almost trivial, like come up with the funniest joke that you can in 10 minutes or 20 minutes. And you would start programming groups of people. You would have a mechanism to vote on which joke was funniest, for instance. And then you could repeat the process several times. And there's lots of different tricks you could employ. Like you could divide the group into two. They each come up with a funny joke, and then they return and pick the funniest joke. And then they split up again and repeat the process or something like that. I mean, there's lots of different tricks you could use to divide the people and do some computation and then come back together. And this could help you make a decision on the funniest joke. And it would also help you create the joke too, right? So there's the decision-making part to evaluate the output of the program. And then there's, there's lots of different components of the program. You could break it up and then it's kind of a trivial program. It's not very interesting, but it would be just a case study, like a little scientific study, right? You got to try to simplify things. You can't bite off too much to chew on and then just sliding around all the time. You're not getting any progress, right? So you pick a really small, little tiny problem and try to do that, see how far you get and try to learn some fundamental rules of how things work.
I love the implicit experimentation of it, which I think is really on the right page. I just shared something which is very interesting about that. It's a tool. I don't know if there's a way, I haven't used it in more than a year, but like they would do it a lot for sports betting, for example, where you would have like real time, but not people like entering surveys and then calculating surveys, but you'd have a real time thing where it kind of looks like you have a bunch of outcomes around a hexagon. And there's a puck in the center, and people are trying to drag the puck to the outcome that they think is most probable. But this is happening in real time, and you can choose how hard you want to drag the puck. And you're maybe doing this with like 20 other people.
Okay.
And they've seen phenomenal predictive like results from that. And that's like their protocol, I don't know, tool for making decisions, but I just thought that is like an experiment which has yielded some really interesting things.
It's kind of cool. It reminds me of something that they do in the Internet Engineering Task Force. And when they want to make decisions about how domain names work and stuff like that, they do have consensus decision-making approaches, apparently. And one of the things they do is they just hum. Like you have one person at the front of the group who obviously has a disproportionate amount of power, but they listen to the level of the humming and the pitch of the humming. And I don't know how many people they have in the room, I guess 50 people or something, 50 engineers, and they want to make a decision. And if you really feel strongly about something, you hum extra loud. And so the sum of their humming is like, I guess it would be logarithmic sum. And then, so you have this interesting approach for doing kind of voting, but it's not 51% by any means. It's something very different. Yeah, so it sounds like kind of a similar approach.
Do you have any documentation or any resources you could link to? I'd love to learn more about
On
that
that?
example. Yeah.
I'm sure I remember reading about it. I think it was on Wikipedia. IETF consensus.
And is the humming a signal for approval, disapproval, or just something in general that like requires further conversation?
I think there's a question posed to the group. They have a protocol, right? Or a rule set. And they pose a question to the group, and then because the humming is pretty vague, right? You can only be plus or minus. So let's see. Consensus and humming in the IETF. Rough consensus. Yeah, there's a Wikipedia article on rough consensus. Please hum now. Making decisions at the IETF. Oh, it's a PowerPoint. Okay, chances are you'd find the above aphorism perfectly suited to a ragtag bunch of hackers, but you might not expect it to be the unofficial motto of the internet industry's most influential standards body, the Internet Engineering Task Force. You'd probably be even more surprised to witness a room full of engineers humming for their favorite data structure. But as this video shows, that's precisely how the IETF gauges its constituents' opinions on controversial matters. Huh.
Can you link that, please?
Yeah, I'll link that. But if you search IETF consensus humming, you'll find lots of links like that. So Wikipedia article here on a rough consensus. There you go. Yeah. Okay, so this is interesting. And in the Wikipedia article for rough consensus, it says that the term was first used by the Internet Engineering Task Force in describing its procedures for working groups. So they're not just stealing ideas from other people, they're doing pioneering work on how to make decisions as a group, I guess. That's kind of cool.
Yeah.
Leave it to a bunch of engineers to do that kind of thing. Makes sense though.
Yeah, and this relates. Well, Lauren just read a book by this author recently, and she put it in one of the emails. But just an example that's coming to mind that I wanted to share is: are you familiar with David Graeber?
Yes, I have read some of his stuff. I don't remember if I ever read his book, but I definitely read these long interviews that he does about his book.
Okay, about like the recent one, like about prehistoric man and.
Oh no, I haven't seen the recent one. I've heard about it, but I haven't read the recent book. I thought he died or something. Didn't he die?
Yeah. He died last year. But there's a book that just came out, so it was like his last book, which he wrote with a writing partner. And just one of the ideas in that is that like he's kind of dispelling or arguing against this narrative that we have of like centuries, I don't know, before Christ or even in like the first 1,000 years after death, of like hunter gatherers, and that was just like a very like it was like the hunter gatherer phase of humanity. And what he's really going to is he's going to archaeological examples and examples of things like burial sites as well as large structures along the lines of Stonehenge to say that actually the evidence shows us something really different. It actually shows a seasonal variance in the types of lifestyles and cultures that our ancestors lived with. So specifically, it was different in some contexts, but often in both North America and in Europe. In the winter, or excuse me, in the summer, groups would be like distributed, and they would be more like hunter gatherers, and they kind of go to where the food is plentiful. And then in the winter, they would all gather. But when they gathered, their governance and culture completely changed. So maybe when they're in hunter-gatherer kind of distributed small packs, it's like patriarchal, it's kind of command and control, it's like top down, like you're surviving, you're on the hunt, that type of thing. But when they would come together in the wintertime, then it would become much more kind of softer and like much more ritualistic and much more like even power structure, much more giving. So not only did like their place in space change, but the whole way they interacted change. And his point, and the reason why he was writing this, is to say that we can do the same thing. We can do the same thing in our world. There doesn't need to be a single system, and we don't need to be stuck with the status quo we're given. We can experiment, and we can explore, different types of things that serve us. So anyway, it seemed very, very relevant.
Yeah, sure. It sounds like a really interesting book. I should definitely check it out. It takes a while to read a book, right? So you have to sort of commit.
I'll try to find the link, the article that I found it, because I didn't read the book. I read one short article and then a longer article.
Yeah.
Also, just know if I randomly hop off the chat, sometimes my computer dies. So I just want you to know that I'm not leaving you hanging if that happens.
Sure. So Vinny didn't come for 2 times in a row now.
I hope he's okay. Yeah, he's probably just busy. If he's traveling,
Wasn't he going to a conference in Egypt or something? They were going to go on a boat. And,
yeah.
Anyway.
Yeah.
Yeah, I live in Cornwall these days. It's a little tiny city in Ontario. So I don't have a whole lot of friends and stuff. It's nice to get together and talk about some interesting stuff with people every once in a while.
I really agree. I mean, I'm still in Croatia. I'll be back in North America. I'll be in DC. I have a flight on December 28th. Because that's where my mom is, so I'll go spend some time with her.
Yeah.
But just wanted to say that like I'm kind of in a village over here, and there's certainly there's a couple people I can have these types of conversations with, but even in the pandemic, like not seeing like a couple of engineers, no surprise. And so as soon as like one is an engineer who also likes bikes, so then all of the stuff about like pure production, it can come right in. But this like level and depth of conversation, I mean, I resonate with you basically.
Yeah. So you're in Croatia then. That's really interesting. I was in Croatia for, I guess, 2 months or something. And do people speak English that much there? It was like kind of depends on the area, I guess.
Mm-hmm. In the main places and like in the like along the coastline and stuff, it's very common. My partner is from here, and so I've been in Croatia on and off since 2016. That's mainly in Zagreb, but in the past couple of years, more like continental, so more east towards Hungary and Bosnia. So here it's like agrarian. It's like lots of fields and agriculture and stuff like that.
It's pretty cool.
More or less flat. But yeah, so I just always say that to clarify, like, I'm not on or to set the appropriate expectations that like I'm not on an island or on a beach. It's like more like southern Austria.
That's pretty cool. It's a very interesting world. The whole Europe is, well, not all of Europe, but it's certainly a very big place. There's a lot of variety there, but they're more prone to supporting social stuff. Like they have some hacker spaces and abandoned buildings and stuff you would never see in North America. It's just much more like the European Union too. They fund some stuff that's quite interesting sometimes. And yeah, they just have a more interesting world in a range of ways there.
Yeah, I mean, like here in terms of politics, I have a friend who's told me like the far right party here is maybe like as liberal as the Democrat Party in the US. And like the stuff that they would like never take off the table in terms of like, healthcare and like education and all that type of thing. That's just like taken for granted here, no matter where you are on the spectrum. And the US, it's like this huge political fight going on for decades.
Yeah, exactly. It's pretty crazy. If more people had traveled to Europe, then they would have a much more open mind about the possibilities there in terms of different political approaches to doing things and stuff.
Yeah, and there's just something so interesting about like, it's not like it at all in the States, even though you have maybe some similar administrative things going on. But I think language is a big part of that, where you can drive like 3 hours, and now it might not be an entirely different culture, but it can be a pretty fucking different culture with a different language, and it's like a different world that you're in.
Yeah, I saw that too. Yeah, it's pretty cool.
And so
Anyway,
tell me, like, what I've been curious. Like, I always love connecting with you and talking with you on these chats. Like, what are the things that you're kind of exploring or focused on or working on these days?
well, have you heard about my undertaking called the Manufacturetron?
You told me a little bit about it, but basically a machine which can make most things.
Yeah, so right now we have 3D printers and we have CNC machine tools. And 3D printers is a very broad category. CNC machine tools is a little bit more narrow. You got the mills and you got your lathes, right? And the mills are the things that can make a wide range of stuff. Lathes are pretty limited. And so what I want to do is make a machine that it combines, you put layers down and then you follow it with a milling operation. It's a rotating cutting tool under the control of a robot that moves in 3 dimensions. And so what you're going to do is you're going to build up basically a mold out of this material that's kind of like plaster of Paris. And so I know I'm skipping over a lot of details, doesn't help much, but every time I try to explain the details, it just like doesn't go very well. So the fundamental idea is that there's layers upon layers being deposited, but they don't get deposited like in a 3D printer where it's just a little point deposition. It's the nozzle that goes around or the laser beam that goes around. They get deposited as entire rectangular layers all at once. And then the layer gets certain areas very precisely removed by the milling machine. So the great thing is that milling machines are incredibly accurate, right? And you can also you can get very small rotating cutting tools that are like a fraction of a millimeter wide. So you can do very small details. And you can also get very large cutting tools that will remove lots of material really fast. So so for the areas where you don't need a small tool, you can get the stuff done really fast. So anyway, what you're going to do is you put a layer down, you remove stuff selectively with the tool, you put another layer of material down, and you again remove stuff, and you just repeat that process until you have this block of stuff. And then basically you're going to remove the support material with water, like you dissolve the support material away, kind of like with 3D printing, you can have support material, right? And then you're going to have a nice mold. But the thing is that the mold is really accurate, and it can be essentially any shape you want, as long as you're willing to make the layers thin. You never really need to make the layers thinner than about 0.5 millimeter. But if you're willing to make the layers really thin, then and you're willing to use a selection of end mills of widely varying sizes, so that you can make small details, like because a large end mill can't get the little details, right? But if you use a wide range of tools, then you can make like really almost any shape. You can't make hollow shapes, and you can't make stuff like fabrics. Fabric is like an enormous number of extremely complicated little fibers, right? But essentially anything you can draw on the computer, it turns out that you can make. And this was the key realization that I don't think other people had made. They had assumed that you would need 5-axis milling machines and stuff like that in order to make a reasonably wide range of shapes. But it turns out that you can make essentially anything, any contiguous object, like a homogeneous object, by doing this. And then you fill the mold with plastic, or it can be fiber reinforced plastics. Because the great thing about this is that if you mold an object as a complete object in one step, you can have little fibers of carbon fiber extending throughout the different regions of the material. Like they can be a fraction of a millimeter long or something, but they all overlap, right? So that gives the material enormous strength. But the problem with 3D printing is that because one layer has to be bonded to the layer below, the fibers, they can't extend into the previous layer, right? Because it's already a solid. So although there's various 3D printers that use carbon reinforced plastics, they have very poor strength along the dimension, the vertical dimension, the pulling dimension, because the layers are only bonded together by the base plastic material. The fibers don't help between layers. So that they're not very strong. But in this case, you can make a nice strong object. You can also use the mold because it's plaster, right? Well, it's like plaster, so you can put aluminum in there, aluminum alloys, and some aluminum alloys are quite strong, almost as strong as steel. Some steel alloys, there's overlap in the strengths of the two alloys, and so there's quite a lot of potential there. And so the theory is that once you have a machine that you can make practically anything you can design in CAD, you can make all kinds of interesting stuff, like airless tires. You can make the milling machine. You can make many of the parts of the milling machine itself. And we just, right now you can't do this. A lot of people don't realize this, but if you have a drawing of the thing in a computer that's like yay big or whatever, and you need it made to within a couple microns, like the surface can't deviate from the computer model by more than a couple microns for any of the surfaces of the object, then it's essentially impossible for a lot of things. There's a lot of shapes you can't make to that degree of accuracy because you can't get the rotating cutting tool in there to cut the stuff. And also, secondly, the milling machine is under enormous amounts of force during the cutting process. So the tool tends to deflect a lot and stuff. But yeah, so, and 3D printing can't make accurate stuff right now. Like even the best 3D printers that exist today, they cannot make stuff that's accurate to more than 1/3 of a millimeter or so, in terms of net accuracy for the whole thing. Like you can have a hole that's within a fraction of a millimeter in diameter, but if you have a large flat plate, then the plate is always bent slightly, and the edges of the plate are going to deviate by more than fraction, like 1/3 of a millimeter, from the ideal shape that it's supposed to be. So there's a lot of stuff you can't do. You just absolutely cannot do it right now, no matter what amount of money you're willing to pay, really, unless you very carefully take some hybrid approach and you glue together pieces and stuff like that, which is incredibly expensive and not at all practical. So I'm hopeful this machine, this is my major undertaking. It's kind of longer term, but I hope to have I think I can make a prototype in a couple months. The major problem is the software because of the slicing process. It's like kind of the equivalent of a slicer for a 3D printer. It has to be done. Yeah. But I have high hopes for the potential. But the thing is, it's been kind of a long time now, and 3D printers have advanced a lot in the intervening time. So it's kind of discouraging. But there's nothing. This is geared towards the context in which like an open source community, like a little community, wants to make things, powerful, capable machines that will help them do real things, whether it's farm equipment, it can be engines, it can be all kinds of stuff, food processing equipment, it can be a loom, it can be another milling machine. And this will help with like a very large fraction of the parts that need to be made to do that. And even if you want to make stuff like semiconductors, the truth is that if you want to make semiconductors, you're building that technology upon a base of other technologies. And so you need chemical engineering processes to produce the chemicals that you're going to need. But you also need quite a large range of mechanical parts that are quite precisely shaped and made out of quite a range of different materials. And right now, that's incredibly complicated and difficult to make all those little parts. If we had one process that could really make highly accurate parts of any shape you want out of a wide range of materials, then that would really, really help reduce the cost of almost any other engineering undertaking that you want to pursue, except for software engineering, of course. Any kind of physical equipment that you want to make, you always have a major problem with sourcing the components. They come from halfway across the world, like even something as simple as a motor. You want a 20-watt motor that has this RPM, that runs at this voltage. It's actually surprisingly hard to get at a reasonable price. I found this out the hard way in a number of cases. And then if you want anything even more complicated, like a pump or something, which is a motor and another piece, then you're almost out of luck. Like you're lucky if you can get what you want at a reasonable price. You can get it, but it's going to be ridiculously expensive. So yeah, I'm optimistic. Yeah.
So you mentioned the software. I mean, so what are like the specific things that, like, what are the areas that you're hoping? Well, actually, like, are you dealing with any blockers? Like, are there any areas where you're trying to make progress and it's difficult?
It's quite a large range of things, and I thought through them, and I have some proposed approaches to, which helps a lot, right? Because you can work, you're not confined by a certain approach until you go down a certain path, right? Right now, I'm not very confined. So the object has to be sliced. It has to be analyzed and sliced into layers that can be produced with the milling machine. They have a certain shape, which is that the end mill can always reach in that particular slice. And you can always slice the object. Like I say, if you're willing to use thin enough layers, any object can be sliced in order to produce slices that can be produced through milling. But so that's one step. So the step is to analyze the object and divide it into slices. And then you take these slices and we have to produce the path. It's just a segment of straight lines that are connected together, which the center of the tool is going to follow. And because it's called the control point, and the G code that runs the 3D printer or our milling machine, it always talks about the control point and the location of the control point. So so these little lines have to be offset from the surface by the diameter of the tool or whatever, right? They can't be exactly on the surface. So you have to calculate all that stuff. And there's some libraries and stuff to use to do that kind of thing, but they don't produce tool paths that are optimal. But what I've determined was that it looks like probably the optimal tool path to use is basically it follows the path of a drop of water. Like here's your surface, right? And here's your cutting tool. And almost always the tools will make a constant Z level, for instance. So the tool goes around in a constant Z level and approximates removes the material as well as it can from the surface of the material. And then it goes down by a set amount, and then it again tries to remove material as well as it can. But it's actually much more efficient to go down essentially the same path as a drop of water rolling down the surface. So at any given step, it has the maximum Z drop that it can muster without gouging into the surface. And so this is something that's a little more complicated and not something that existing software packages can do. But it would help a lot. I think I might skip that for the machine. Something with manufacturing that often happens is that you can make something 5 times as effectively just by changing the software a little bit, like 5 times as fast. But it's just a lot of work to change the software, so people just hobble on. It's still economical to make the thing, even if it takes 5 times as long to make it. So for the early prototypes of the Manufacturotron, I probably won't bother much with that, but it gives you an idea of the kind of challenges involved, right? So it's mostly the slicing, and then you take each slice and you produce G code that tells the tool where to go to form that slice, and the selection of tools rather, because there's a whole magazine of tools. You use the biggest tools first, and then you switch to the smaller tools, and that's pretty much it. You just link those G codes together, and you interleave the deposition processes in between those. The deposition is super simple. It's basically just one line of G code that says deposit material up to this level. Might get a little more complicated than that in the longer term if you want to be efficient with material you use and stuff. But if it's just the first prototype, you can use a little bit of extra material and stuff. So yeah, that's it. Slice the object, make the G code, interleave the deposition steps. And that's pretty much it. But it gets complicated, right? So I'm trying to work with mostly Python, and I'm going to make it cloud software. So that way I can be pretty intensive with the computation. And that's not a major problem because I can throw a ton of cloud computation at it. The calculation of the G code is extremely easy to parallelize. So I can put it across a large number of computers and get some computation done reasonably fast. But I'm not really very good at software engineering. In fact, I'm pretty much an amateur at that. So that's definitely probably one of my biggest barriers.
Is in the context of this machine, like, are you kind of thinking about this in like an open source pure production way, or are you kind of thinking like more proprietary?
The machine, the hardware itself, it's definitely going to be open source. It's impossible to patent it because similar processes have already been patented and the patents have expired. So that's kind of an ideal situation, right? Nobody can patent it. At the same time, you don't have this patent owner who's just being nice to everybody and just promises that they're going to be good when you don't know for sure if they will. So for the software, I don't know what to do. I have to find a good business model. I would like to do everything open source, and that's what I intended to do from the very beginning. I first launched on this mission during my visit to Open Source Ecology. This little place in Missouri. I don't know if you've heard of them. Have you heard of them?
Yeah.
Yeah, it's kind of a cool project. They've been in the doldrums for many years now, but at the time they were very active. And so I started thinking about this. It's developed a lot since then, but based on the challenges we were experiencing. And it's very much inherently geared to open source production. It's just like built in that an engineering firm might have some use for it, like an engineering firm that's producing small quantities of production parts or doing some prototyping. But it's just the people who are going to have the most use for it, or it's going to be like a small village or a small community of people who are producing things you can't buy, which is going to be open source stuff. So yeah, I mean, it's not really tempting to do anything in a proprietary way because, like I say, the patents are already there. So for the hardware, it has to be all open source. But the software, I don't know. Like if it's going to be cloud anyway, I don't know.
So my next question from there is like, do you have people that you're collaborating with, for example, people who can help on like software, like, or are you interested in finding people to collaborate with?
Yeah, I'm definitely keeping my eyes open for collaborators, and I have some money saved to pay them at a modest wage. I have about $40,000 set aside for the project to get it to like a Mark One, a machine that's producing parts that at least are demonstration parts. They have to be accurate and they have to be strong, and they have to be a reasonable complexity to show the main three hallmarks. But one thing I can compromise on is that it can require a great deal of manual intervention to make the part. Like even if it doesn't have to be economical to make the parts. It can cost a lot of money. It can take a lot of time, but it has to prove the three essentials of high accuracy, high strength, and extreme geometrical complexity. So I do need some basic software working for that. I think I've tried doing, I want to like make sure I have the process figured out well at an abstract level in terms of, there's a lot of details because the way that you have to get the layers to bond together and stuff, right? And so I've been doing some programming in Fusion 360. I can manually make like 10 layers in Fusion 360, but it'll take me hours and hours. So it's not economical, but I can do that. And then for the deposition, I'm not even going to have a robot that does the deposition. I'm just going to do it manually for the first Mark One. But I'm very much looking for collaborators. If you know anybody or be interested in yourself, then yeah, definitely hook me up. And I've got a fair bit of money so I can pay them and stuff.
Yeah. So all I was gonna say is like I would just recommend like, I mean, because we're all going through the same stuff. Like Lauren is going through the same stuff. I'm going through the same stuff. Like trying not to do this by ourselves because that's a big area of like where we can get stuck. One thing I wanted to say before getting into that is as soon as you mentioned airless tires, I just wanted to share a link to an open source cargo bike design that I've been super into. And the whole time that I've been thinking about this, I'm like, you could literally make all of this from a 3D printer except for the tires. So
and not the bearings. There are some limitations on the rolling element bearings are too accurate. And there's a couple other things you can't really make because the accuracy requires is too high or whatever. But yeah, you can make a very large fraction. I would say that.
Okay. Well, that's amazing. And I do want to hear more about airless tires, but on a quick note, I mean, what I think I could just share, because I'm in the process of like thinking about this stuff all the time myself, is just maybe processes that could help. But one specific thing, are you familiar with the precious plastic machines?
Yes, I am. I try to keep on top of open source hardware stuff, like mechanical hardware, especially.
Okay.
Yeah,
So they have a Discord, which is not just for precious plastic, but it's like their community called like One Army or something. They have like 20,000 people in it.
Yeah, I went to the Discord and poked around and stuff. It's interesting for sure.
So,
I should
it's really
around the collaborators. Yeah.
That's it. That's exactly what I was going to say.
Yeah.
And because the software aspects of it sounds super specific, I'm not even sure that I could think about something else. So the other just thing which would be interesting is that, you know, you kind of have a budget for this, but it would be interesting to think about, like, from a way of de-risking, but also in terms of validation. If there was a way to say, like, this machine, like, we're going to make this machine and then we're going to be able to sell this machine, like, you can make it yourself or we can sell it.
Yeah.
But also, like, you know, what is an output? So for example, can this, like, machine churn out cargo bikes? And so now you can sell, like, cargo bikes for like $100.
Yeah, exactly.
And then maybe you could say, like, you could fundraise for the machine by saying, hey, do you want a cargo bike for $100? Like, you know, here you go. And we're going
Yeah,
to use
like
the
Kickstarter.
funds.
You can
Right.
have rewards, right, on the Kickstarter.
Yes, exactly. And so, because that's a model I explore a lot. Now you can do some interesting things with that, where maybe you can sell, like, so Kickstarter is just the rewards, right? And it's kind of like, I don't know, they're not fungible, right? Or they're fungible. Point is, like, you can't exchange like Kickstarter. Like, you buy a cargo bike on Kickstarter, you can't exchange that with anybody.
Yeah.
But you know, I'm doing some work getting into, here's like a little demo, if you can understand the context of it. This is with the guys who are doing, like, that grassroots economics, community design, currency stuff.
Mhm.
That link that I just dropped, it's a little demo for the idea, and it's informed on their work. It's, like, informed by the contracts that, like, they're actually seeing in real life. Not that this would be that useful for you, but just to give the idea that, like, you know, say I really believed in your idea, and I believe there's going to be a lot of people who want to get cargo bikes from you. So maybe I want to buy, like, 20 vouchers for cargo bikes that you're going to produce. So now, instead of getting $100 from me, you're getting $2,000 from me.
Yeah.
And I get one cargo bike for myself. Maybe I get a couple for my family, but then I can also, like, sell those vouchers on later if I expect there's going to be kind of a rise in value for them.
Yeah, that's actually a particularly interesting idea. Because suppose I did this. Suppose I went, you can have an object of whatever shape you want that's no larger than this dimension. It can't be larger than a 10 by 10 cube, but it can be any object you want made of this material. And it's going to cost you $100, not $100, $50. Then the people who understand the process, or they understand the value that it has, can get in on the ground floor and buy a bunch of these vouchers. But then later on, they sell the vouchers for even more money. So they're financially speculating, right? Because so they're hoping that the value of the vouchers is going to go up. Once people understand the word gets out about what you can make, then some engineering companies are going to say, hey, we need this stuff manufactured, and it's worth a fortune. It's a little medical device or something. It needs to be made out of stainless steel, and it has to be very precise, and it's a ridiculous shape. Then it's going to be thousands of dollars to get that manufactured through conventional means. So your voucher that you paid $50 for is now worth thousands of dollars to this company, right? So you sit there and you speculate. It's an idea, but then the other thing is that the company itself might want to capture that. Like, I was thinking Onshape, or no, it's not Onshape, it's Shapeways or something. They produce 3D printers. No, Stratasys, they produce 3D printers, but 30% of their revenue actually comes from 3D printing parts. They just have a farm and they produce parts, and then they sell the parts because they know how to use the printers and they know what they're capable of. So instead of selling the printers, they just sell parts with the printers. It's another possibility. But yeah, I definitely have my work cut out for me finding a business model.
But I don't think it's that hard. I mean, I've been talking with, so there's a guy who could be interested in collaborating. I mean, I don't want to make any guarantees because he's very much like trying to, like, lead a similar effort. But what he's doing is an extension of the precious plastic machines, which can also accept trash and biomass as inputs.
Okay.
And so there's like his name is Sam Smith. Maybe you've come across it. The project called, like, the Metabolizer or the Trash Printer.
I think I might have seen the Metabolizer.
Okay, so that's what it is. So it's like you have your plastic shredder, then it has, like, a chamber for biomass. So, like, I don't know, sticks and whatever grass shit you want to put in there. lovely grass you want to put in there, and then it has a chamber for like trash, and also has solar panels. So it kind of like burns the trash and uses the solar panels to create the energy, which somehow maybe it burns the biomass. I'm not sure, but it heats that. It turns it into biochar, and the electricity turns the shreds the plastic, and it also has like a CNC type movable gantry extruder, whatever the fuck. So it's a different type of, you can do different types of things with it basically.
Okay.
But the point is, I was talking with him about some similar stuff, and it's just like investing. I think it's just the same thing as like raising money from crowdfunding, whether you call it rewards crowdfunding or investment crowdfunding. But the idea is that the investment is directly aligned with the utility of whatever you're trying to do. So the utility being the parts of the machine, the things that are going to be made. It's like investing basically in the value flow itself, as opposed to into the entity. And I think there's something interesting about that clarity.
Your audio flaked out briefly.
Oh,
Sorry.
I was just saying the idea, you know, if you think about like the vouchers and their like service contracts, you know, this model, it's essentially like investment crowdfunding. But the point is that you're not investing in an entity, you're investing in like the future value flows of a specific like utility function. So you're not investing in saying, I have 0.25% of this company. You're saying that like, I own the rights to these like future things that will be sold, and they will be sold for more than I bought them for. And so those future things could be machine parts. Those things could be full manufacturetrons. It could be the outputs of the manufacturetron. It could be all three.
Yeah.
Just, I think there is something to be considered for having the investment being directly aligned with that outcome. I don't know, in terms of transparency or clarity or pragmatism, something about that feel, or alignment, like literally alignment.
Yeah. Yeah, there's definitely potential there. But then you can make good stuff and you can put it on the market, and a lot of time people don't buy it much. They can make good, suppose I made airless tires for bicycles or something. And it's the whole marketing stuff, right? It's still kind of unreliable. So you can, it's just a lot of different connections and a lot of different parts, and they tend to be, each one is kind of unreliable. Like an engineer wants to make the system as simple as they can, right? Because it tends to be more reliable. So when you have this long chain to collect and distribute funding again, it worries me a little bit that it's kind of baffling what goes wrong sometimes.
Well, the only thing that I'd respond with is the idea here is that you're not actually like, so this is like pre-buying almost.
Yeah.
It's
Yeah,
like
you're
prepayment.
trying to simplify it a little bit and reduce the risk anyway.
It's risk. It's like, it's about risk and validation.
Yeah, definitely. But I still have to get through the initial stages. Like I'm trying to make some demonstration parts. I don't think a Kickstarter would be very successful without a demonstration. But so.
Well, I mean, I think that's a good point in general. Like, or maybe in that case that you would just want to. So if there's like greater risk involved because the thing is farther from fruition, then like for greater risk, like higher return. And I'm not saying like selling equity, but maybe in that case, it's like in the future, I think I'll be able to sell this machine for like, you know, $2,000 fully configured, like send it from point A to point B. You know, if you like help fundraise now, you can get it for, I don't know, $200.
Yeah, well, I can't be
So
that, but yeah,
what?
the general idea makes sense. Yeah.
Right.
Yeah, also it's like it's more, the other thing is that because it's directed towards a community, people like things that they can put in their basement. So you got these relatively wealthy people that'll buy 3D printers so they can put them in their basement and make parts. But this machine is a little bit too expensive and a little bit too big to put in your basement. So, and it's a little bit too complicated to operate. You do have to have a little bit of skill to operate it. Not so much skill, but just like, you know, it's a little bit of learning curve. So yeah, that concerns me a little bit. Can be a little bit of a barrier for the crowdfunding. But yeah, I mean,
Yeah,
there's a lot of potential. You've
Yeah,
gotta-
and the guy working on Metabolizer was going through the same thing where he is like, this is a tool for machine. So then we were thinking like, so maybe then the deal is like, whatever the crowdfunding looks like, it's like encouraging people to crowdfund with their community because you don't have a need for this just yourself. So
Mm.
like, I don't know. So one of the things he talked about is like, whichever community raises the most money, like he'll go and like build it like on site, like with them.
Okay.
And then like, I don't know, you strip away the uncertainty so people are sure that if they're putting money in, they're getting something out. But
Mm.
basically, his idea is like, yeah, like people are not contributing to buying the machine for themselves, they're contributing to buy it for like their local commons in a way.
Yeah, the local Fab Lab or whatever.
Yeah,
Yeah.
that's a,
There's a lot of potential there. Lots of work to do. I'm still at the initial stages of finding a collaborator, getting some stuff on the software, but I'm making some progress. Yeah, it's a long journey, but probably within a couple months I'll have some demonstration parts. I think in a couple months, we'll see, like maybe 4 months from now.
cool.
Yeah.
Well, so a quick thing is I'm gonna jump and go on, but like let's keep the conversation going on this because I have a couple things that I want to share with you. Do you want to jump as well, or do you just want to like stay on as host in case they want to come back?
I think I'll jump. Yeah, I'm gonna bounce, but
Okay, so I'm
it's
gonna
11
stop
o'clock
the
now.
recording.
What happened to